We continue our exploration of trigonometry through trigonometric functions of any angle. We have looked at right triangle trigonometry, which assumes that the angles are in a right triangle, so they are acute. And we have used the right triangle trigonometry formulas. And now we are going to go to any angle, which means obtuse, convex, even negative angles, and we will use a Cartesian coordinate system for that. So in a Cartesian coordinate system, we want all the definitions of acute angles to remain as they were. And if we have an acute angle theta in standard position, then its terminal side will be in quadrant 1. If we select a point on the terminal side of that angle in quadrant 1, and we assume that it has coordinates x, comma, y, then if I draw the length y starting at P and going towards the x-axis, then I see that I have created a right triangle with the acute angle theta at the origin. Opposite to theta is the length of the coordinate y, and adjacent to theta is the length of the coordinate x. And the distance from the origin to point P will be called r, and it will be the square root of x squared plus y squared in that right triangle. And according to the right triangle trigonometry, the sine of theta should be the opposite, which is the y coordinate, over the hypotenuse, which is the r. And the cosine will be the adjacent, which is the x coordinate, over the hypotenuse, which is r. And the tangent of theta will be the opposite over adjacent, which in quadrant 1 will be y over x. Then the other functions will be the reciprocal of those. So we try to maintain the same definitions that are valid in quadrant 1 and generalize to all possible quadrants, keeping in mind now that x and y could be negative quantities. As lengths, they will be positive, but the location in the Cartesian coordinate plane will be revealed by the sign of those. So we maintain the same 6 trigonometric functions. We consider y to be the opposite. We consider x to be the adjacent. R is the distance from the origin to a point P on the terminal side of our angle, with P having coordinates x, comma, y, and we now define the trigonometric functions of any angle as the sine of theta being the coordinate of y divided by r. Y is the coordinate of a point on the terminal side of theta. The cosine of theta will be x divided by r. The tangent of theta will be y divided by x. The cosecant will be the reciprocal of the sine. The secant of theta, the reciprocal of the cosine. And the cotangent of theta is the reciprocal of the tangent. So I'm going to erase those notes. In our example, our angle theta is in quadrant 2. And the way that we will be sketching that would be that we will be picking a point at on the terminal side. We will sketching a right triangle attached to the x-axis, and we will know that the opposite, that the y coordinate will be positive in quadrants 1 and 2 and negative in quadrants 3 and 4. And the x coordinate will be from the origin to wherever our vertical line segment hit the x-axis, and it will be positive in quadrants 1 and 4 and negative in quadrants 2 and 3. Pay attention to the signs of x and y in different quadrants. R is always positive. There is a mnemonic device if you want to use it. It says all students take calculus, and I wrote these letters in the quadrants in the way they are defined. So quadrant 1 was the A, and quadrant 2 was the S, and quadrant 3 was the T, and quadrant 4 was the C. And this indicates which trigonometric functions will be positive. All are positive in quadrant 1. The sine is positive in quadrant 2. That is because the y is positive. The tangent is positive in quadrant 3, and that is because x and y are both negative, and the tangent has both x and y. And calculus is the cosine will be positive in quadrant 4, and that is because x is positive in quadrant 4. R is always positive, and then the y switches signs, of course, as defined. So this is the concept of how we will define the trigonometric functions of any angle in standard position, with the initial side on the positive x-axis and the terminal side in some of the quadrants. What is the reference angle? The reference angle is the acute positive angle between the terminal side of theta and the x-axis. Any angle theta and its reference angle have identical trigonometric functions, except maybe for the signs of positive or negative. So the reason we want the reference angle is because it is very easy for us to use this right triangle to apply the definitions of the 6 trigonometric functions. And if theta is an obtuse angle, the reference angle of theta will be the acute angle between the terminal side and the x-axis. If theta was a convex angle, let's say in quadrant 3, the reference angle would still be the angle created if I would pick a point on the terminal side of theta and just attach it to create a triangle that is attached to the x-axis. So the reference angle would still be an acute angle that represents that right triangle. So acute angles are in quadrant 1. In quadrant 1, all the trigonometric functions are positive. The triangle that I sketch attached to the x-axis resembles that of the reference angle in quadrant 1. Therefore, the y and the x values and the r have the same absolute value, but the signs are different depending on the quadrant that I'm in. So the reference angle is a great way for us to remember only acute angle or right angle trigonometry and then generalize it to the Cartesian coordinate system. So if I have the angle negative 125 degrees, which would be, it's negative, so I'm going to start from 0 and I'm going to go in the negative direction, and I'm going to pass 90 degrees and I will not pass 180 degrees. So this would be my angle, negative 125 degrees. Then the reference angle will be the angle that the terminal side makes with the x-axis. So if I had picked the point on the terminal side, and I would just draw the right triangle that is attached to the x-axis, then that acute angle would be the reference angle. How much is that? Theta, that's the reference angle. It will be 180 minus 125. And 180 minus 125 is 55 degrees. That means that all the trigonometric functions of 55 degrees and all the trigonometric functions of 125 degrees are equal to each other in absolute value, except for the sine. Also, I know that the tangent in quadrant 3 will be positive, so it will equal to the tangent of 55 degrees, but the sine and the cosine will have opposite signs. Now, I can try to just, even though they are irrational numbers, I can just write to see how it would look like. So if I do the tangent of 55 in my calculator, and I see some number, and then I do the tangent of negative 125 in my calculator, I will also see the same number. If I do the cosine of 55, I will see some decimal approximation of the irrational value, and the cosine of negative 125 will be the same, but negative. 5 pi over 3 is a positive angle. So I'm going to start at 0. I'm going to move in the positive direction. The slice of pi is pi thirds, so 60 degrees. I need 6 of those, 3 of those to get to 180 degrees. This is pi. So I need 1, 2, 3 to get to pi. And then I need 4 and 5 to get to 5 pi over 3. So it will be over here. So this angle is 5 pi over 3. The reference angle of this angle is this one, the acute angle in quadrant 4 that I make with the x-axis, and this is 60 degrees, or pi over 3. So if I pay attention to the trigonometric numbers of 5 pi over 3, let's see if I can zoom in a little bit. In a reasonable way, there we are. All right, so if I look at 5 pi over 3, the cosine and the cosine with pi over 3 are identical to each other. The cosine is positive in quadrant 4. The sine is negative square root of 3 divided by 2, and the sine here will be positive square root of 3 divided by 2. So the value is the same, but the sign is different because the sign in quadrant 1 is always positive, but in quadrant 4 it is negative. Negative 19 pi over 3. So I'm gonna go in the negative direction. The slices are pi thirds. I need 3 of them to make 180 degrees. So negative 1, negative 2, negative 3. Keep going. I have to go 19. Negative 4, 5, and 6. Negative 7, 8, and 9. Negative 10, 11, 12. 13, 14, 15. 16, 17, 18. And negative 19 will be here. So that will be the negative 19 pi over 3. So to generate that from the x-axis, I just moved 60 degrees. So the reference angle is again pi over 3. So this reference angle will be still pi over 3. And again, I would expect the cosine to have the same value and be positive, but the sine and the tangent to be negative for negative 19 pi over 3 versus positive pi over 3. And to do an example again, just to see how we can use our calculator, if I do the tangent, let's say, of 180, that's pi, divided by 3, I will find this value that's equal to the square root of 3. But if I do the tangent of negative 19 times pi, which is 180 degrees, and divide by 3, then that will be the same value but negative. So again, I'm expecting the reference angle to have identical trigonometric functions with the regular angle, except maybe for the sines. So I'm going to use reference angles to calculate all trigonometric functions for 120. And of course, this is an example that is in our notes. However, we do have our formula packet, and the formula packet contains the angle of 120 degrees. So I don't really have to use reference angles for that, but it's a good practice. So 120 degrees is here, starting in standard position. The reference angle is 60 degrees, which is right there. So I'm expecting the cosine of 120 degrees to be the same with the cosine of 60 degrees. Only the cosine is x over r, and x in quadrant 2 is negative. Therefore, the cosine of 120 degrees will be negative. Cosine of 60. The cosine of 60 is 1/2. So I'm expecting the cosine of 120 to be negative 1/2. And again, let me check with my formula packet. Per my formula packet, the cosine is the first coordinate of every point here, and the cosine of 120 is negative 1/2, which is the opposite of the cosine of 60. The sine of 120 will be equal to the sine of 60 degrees. Now the sine is y over r. Y is positive in quadrant 2. Therefore, it will be positive sine of 60. It is positive in quadrant 2. And the sine of 60 was square root of 3 over 2. So I'm expecting the sine of 120 to also be square root of 3 over 2. And again, I'm looking here in my packet, and I'm looking at the sine of 120, and it is identical to the sine of 60 and also has the same sign. Now, the tangent of 120 will equal to the tangent of 60. The tangent is y over x. The y is positive and the x is negative in quadrant 2. So it's going to be a negative quantity in quadrant 2. So negative in quadrant 2. Now, the tangent of 60 degrees, if you remember from the equilateral triangle that we used to find the trigonometric functions of 60, was the square root of 3 divided by 1. And since I am in quadrant 2, it will be negative square root of 3. And you can work with the other trigonometric functions that will be the reciprocals of the cosine, the sine, and the tangent, and they will keep the negative sign of the reciprocal function. Now, some other very important types of problems that are very nice for test questions are coming up here. And for those, we will sketch the angle in the correct quadrant, and we will clearly label the values of x, y, and r, including their signs. So we have a terminal side of an angle in standard position that passes through the point 10, -6, and 10, -6 is in quadrant 4. So this is the terminal side, this is the point, and when I draw the triangle that attaches to the x-axis, the x-coordinate is +10 and the y-coordinate is -6. Now I'm going to use a quadratic formula to find r. So I'm going to say, actually let me write it here, r squared will be 10 squared plus 6 squared. Now I don't need to say -6 squared because I will square that. So the -6, when you square it, is also 6 squared. So r squared is 136, and that makes r equal to the square root of 136. I don't use plus or minus for r. R is a distance of a point from the origin, and it's always positive. So r is always positive. I want to find the 6 trigonometric functions of the angle using the reference angle. Now the reference angle is this one, theta, but I have clearly labeled the x and the y with their signs. So I actually do not need to use the reference angle. I can just use the formulas. So the sine of theta will be y over r, and the y is -6, and the r is the square root of 136. The cosine of theta is x over r, the x is +10, and the r is the square root of 136. If they ask me to rationalize denominators, I can do so. The tangent of theta is y over x, and the y is -6, and the x is 10. The cosecant of theta is r over y. The r is the square root of 136, and the y is -6. The secant of theta is r over x. The r is the square root of 136, and the x is 10. The cotangent of theta is x over y. The x is +10, and the y is -6. Here is another one. Determine the remaining trigonometric functions of an angle theta if the cosine of theta is 3/7 and theta is in quadrant 4. So the cosine of theta is x over r. So I'm going to sketch an angle in quadrant 4. I'm going to pick a random point on the terminal side. I'm going to draw the triangle that attaches to the x-axis. And on that triangle, I will sketch x and y and r. Now, x is the x-coordinate, y is the y-coordinate, and r is the distance from the origin to my point. And because the cosine of theta is 3/7 and the cosine of theta is x over r, the x will be 3 and it's positive in quadrant 4, and the r will be 7, and it's always positive. So I'm going to find y using Pythagorean theorem. So y squared will be hypotenuse squared, which is 7 squared minus 3 squared, which is the x squared. So the y squared will be 40. Now, when I try to find y, I will say that it is plus or minus the square root of 40. And the reason is y could be positive. Now, because y is in quadrant 2, in quadrant 4, it will be negative. So I'm going to choose negative square root of 40 for the value of y, because in quadrant 4, y will be negative. So that will be my y for this problem. Therefore, I can find the sine of theta as y over r, negative square root of 40 divided by 7. I can find the tangent of theta as y over x, and y is negative square root of 40 divided by 3. That's my x. I can find the secant of theta as r over x. The r is 7 and the x is 3. I can find the cosecant of theta as r over y. The r is 7, the y is negative square root of 40. I can find the cotangent of theta as x over y, which is 3 over negative square root of 40. Now, they can ask me to simplify the square root. It is 4 times 10, so 40 is 4 times 10, so I could simplify that. They could also ask me to rationalize denominators, so be prepared to do all of these transformations of the numbers. 2 more problems of this kind. You may want to stop the video and try to solve the problems on your own, or you can just continue watching and then practice doing the homework. An angle that has positive tangent but negative cosine will be in quadrant 3. So I'm going to draw the angle in quadrant 3. I'm going to pick a point on the terminal side. I'm going to draw the triangle that attaches to the x-axis and contains the reference angle. These are coordinates x, y. They will both be negative. The tangent of theta is y over x. So 3 over 7 will equal to y over x. Therefore, the y is negative 3 and the x will be negative 7. I'm going to do Pythagorean theorem to find r. R squared will be 3 squared plus 7 squared. So r squared will be 58. And then the r will be the square root of 58. It's always positive. This is a distance from the origin on the Cartesian coordinate plane. Therefore, the sine of theta will be y over r, negative 3 over the square root of 58. The cosine of theta will be x over r, negative 7 over the square root of 58. The tangent, they already gave it to me. The cosecant of theta will be r over y, square root of 58 over negative 3. The secant of theta will be r over x, square root of 58 over negative 7. The cotangent of theta will be x over y, which is negative 7 over negative 3, and that is 7/3. One more, we have a positive sine and we have a negative cosine. Therefore, we are in quadrant 2. So I'm going to draw an angle in quadrant 2. Pick a random point on the terminal side. Draw the triangle that attaches to the x-axis. The reference angle is this acute angle here. The actual angle theta is this obtuse angle here, or any rotation actually that ends there. The sine of theta is y over r. The y is positive and it's going to equal to 1. The r is always positive and it's going to equal to 3. I'm going to find x using Pythagorean theorem. X squared will be r squared minus y squared, 9 minus 1, which is 8. And x will be plus or minus the square root of 8. And I'm going to choose negative in quadrant 2. X is negative in quadrant 2. So the x here will be negative square root of 8. And again, you can simplify the square root of 8 to make it 2 square root of 2. So to find the sine of theta, they gave it to me, is 1/3. To find the cosine of theta, I'm going to use the formulas. X divided by r, negative square root of 8 divided by 3. The tangent of theta will be y divided by x, which is 1 over the negative square root of 8. I may have to rationalize the denominator if the problem asks me to do that. The cosecant of theta is 3 over 1. The secant of theta will be 3 over the negative square root of 8. And the cotangent of theta will be negative square root of 8 divided by 1.